Hi. If releases feel risky, slow, or chaotic in your company, that's not a bad software engineering. That's missing release engineering. In this video, you will learn how release engineering works in practice. Not theory, not some tool marketing, but a framework I use to ship fast without breaking production. We will cover how to establish release processes based on company needs, how to clarify services by criticality, apply semantic versioning correctly, enforce backwards compatibility, and build low-toil release process that scales up and down with your company needs. So, my name is Mikita Komenko. Today, I have decided to actually talk about my release engineering experience. The things I was able to figure out over the last 3.5 years of creating and managing the release process for dozens of interconnected teams. So it all started with classic startup story of how not to do. No process, no structure, releases is pain in the ass. Deployment was done once in a quarter, and then we wasted 2 weeks by basically fixing bugs. It was bad, but it had a reason to be bad. It had almost no operational cost. Just concentrate on doing stuff. We will care about quality when we start testing it pre-release. It wasn't all dire. It made sense. But if you grow into having customers, you need to grow in your process. The thing is, release process cannot be done in a vacuum. It's a team effort. And whatever teams are, whatever status quo your company brings on the table, it rarely can stop you from making this process work. Even though making things not ideal can be frustrating sometimes, trying to force an entire company and your peers to apply higher standards and make some painful changes to their work, just so your job will be subjectively perceived as ideal, is not gonna do any good, actually. So I want to stop here a little bit and talk about the structure of this presentation. This field is kind of broad and practical, but to make the right decisions, you need two parts. First part is theoretical basics, to understand where to adopt and how. Second part, more practical, basic toolings that will help you manage all the chaos in your company. Now, we are starting the first theoretical part. So, let's start with theoretical consideration. The first one is the fact that there is nothing secret about releases and deployments. Changelog, version, and time of updates are not sensitive information. Don't be a bottleneck. Decide on the way you document releases and deployments, make it company public so everyone can see it, and just move on. It's basic stuff, but quite a few times I heard from PMs and QA guys phrases like, "Oh, on my previous job, there was no easy way to understand what is deployed. And so we need to ping this guy to ask about it." Just don't do it this way. The second point is about development and production environment relations. Ideally, to get consistent and predictable results, we need to somewhat minimize possible changes that apply without human will to actually dictate it. Most of these kind of issues happen during the artifact or image build process. So ideally, after we've done all the preparations, we operate with immutable images on production. Let's be real, AWS or any other cloud resource provider have quite a few moving pieces by itself, so there is always some version of change, like operational system update, security patches, DevOps changes. But we still should minimize the risk when it comes to our software. That's why if quality gate means some sort of manual labor, like manual QA test or whatever, we need to perform it on the same image or artifacts that will be delivered to the production environment in case of success. But here's the catch. Dev environment and production environment is quite different by its requirements. While dev environment needs to be easy to operate by individual contributors with little to no restrictions, so everyone can work fast and efficient. We cannot allow the same rules in production, partly because we have governance regulations and basically GRC, partly because companies have internal security standards and obligations on them. To fix this dissonance, we boom, add in a release process to make this transition, the cycle of preparations and quality assessment. We are moving product through various quality control gates to realize what problems we found and what inconsistencies we need to dig into before allowing it to move forward. And there is where I have, I don't want to say controversial opinion, but still an opinion on the matter. A lot of people in the industry of platform engineering, release engineering, or SRE include production deployment in release process. At the same time, there is no one-to-one relations between both of these processes. That's why I personally separate them as release process to prepare something, and deploy process to apply. The example I like to give to people is that the release of a desktop application doesn't mean you actually installed it on millions of your customer personal computers. You have another set of complications when it comes to updating multiple production environments and relations, regulational paperwork that comes with it. Let it be a separate problem entirely to fix. Now we more kind of like now we have an accent on release process, which is to prepare something. So let's talk about risk and agility balance in release process. It's easy to equalize delivery speed with development speed because we basically use the same vocabulary like agility, agile, speed, velocity, acceleration, which is not the same. By just continuously throwing the project into production, we do not magically create an ability for development to do more work. Quality assurance does not test more in depth, and project managers does not have additional story points out of the air. But then, what's the relation between those two? Like, we already know relation between release and deployment process, but what about development and release? Well, if you take a quarter-long process and just accelerate it through some auto-deployment Jenkins job, you will create an unimaginable amount of mess in development and other operations. It's kind of obvious, but it's important to point out that it is not a way to do this. So, before ramping up the speed, we add quality control to compensate for the mess a faster process will make. The exact controls will be partly described in the second practical part of this presentation. The important thing here is that these quality controls are not free. They add more work and communication to the teams and apply constraints to what they can and cannot do. This is what I showcased on this graph. If you apply speed properly, the X amount of release operations should be performed will be performed not quarterly, but weekly and then daily. It's kind of like increase in the amount of operational work. You can always cut costs by automating more things and hiring more automation specialists, but it's hardly gonna change net income. The faster you go in releases, the more you check things and the more constraints you apply on dev teams. Basically, the more nuanced the work become. And the more people you need. Congratulations, now you effectively transformed most of unmanageable money and reputational damage into perfectly managed engineering spending. That was the first piece to consider about balancing risks and release agility. Fast releases are costly and will make it harder to apply big changes. The second part here is to consider an honest assessment of your company place in natural business progression diagram. Let's look into it more in depth to clarify what I mean by every company state. State number 1, startup. Defining factor is pre-revenue. Things need to be done fast or we will just get out of all budget and we will travel straight up to a death, state. Second state is growing company, a self-sustainable. It's where customer opinion starts to actually matter. The degree of how much it matters decide on how fast your company going, how fast it's growing. So if it's grow fast enough, maybe you don't care that much, but if it's like steady and slow process, then you need to care about them not leaving. So state number 3, plateau. No more easy markets to conquer. Every step of growth get harder and harder, and frankly, top management doesn't care anymore. This is where you kind of like start care about. You care the most about your customers, because now you need to. It's not about conquering your markets. It's about saving what you have. State number 3, things go bad but money still go. It's kind of like the same as plateau, but it's either World introduced changes, but the bureaucracy denies it, or overall destructive changes from various management levels. The line back to plateau is purely theoretical because, well, a lot of times it's either bureaucracy wins or, management just double down to be completely sure that the problem is current course. It may happen. I wouldn't expect it to be. State number 3 is crisis management. It's basically startup 2.0. Based on what happened here, we go either to that step or back to growing. So state number 6, that's, avoid. For both crisis management and startups, there is no need for established or formal release process. Everything will be rebuilt rapidly with no formal process to stop it. That's kind of like summarizes this formal life cycle of a company. Decide where your company is and act accordingly to the need of big changes. If you need more production stability, make releases faster. If you have a need for big reworks, big changes, slow down the release process to free the resources and concentrate more on a smaller number of releases. The next part is actually adapt your work to reality. Because business reality changes over time, there is a need to adjust your process accordingly. This graph is just remodeling of a previous one, but here I want to specifically point out the fact that all this company states is not a specific ideal point, but more of a range of acceptable balance. And the thing is, the boundaries of this range are mainly decided by a desired delivery rate, and your company need to make big changes. Different factors like number of people in every department, their productivity, project complexity, and engineering plans can change these boundaries over time course. And if you fall out of them, you get into a money and reputational loss zone. On the left side of this chart, your delivery time is too low. On the right side of this chart, your team is overwhelmed by the sheer amount of work, and everything starts to crumble. All this balancing stuff, even if I made it into kind of detailed graph, is no exact science. You cannot just go to your product owner and ask him to consistently rate his desire to introduce new products and customer desires to get their stuff faster. The thing is, you need to know what happened around you in company and personally assess where we are, what we are, and what our ability is. And basically take a professional guess on optimal release frequency. So the last thing to consider is that we need to learn from our mistakes. None of our quality gates will eliminate bugs in production environment better than actually learning lessons from our mistakes. In later years, there is a lot of different discussions about what is better, a root cause or post-incident review. I personally like doing them both. At root cause analysis, we analyze the actual problem, like what it was and how it happened, and how we can learn from that. It's basically a feedback loop to our developers. I believe that you can completely shift it left towards separate teams. Team leaders are grown enough people to review all the documented bugs. At the same time, you need to concentrate on the post-incident review. What was our response time? Were there any blockers to fix the issue? How can we remove them? Can we fix this kind of issues automatically? There are all kinds of questions that should be asked on a regular basis as a process by itself. Okay, I'll be honest with you. There is not much I can say about monitoring of production environment because, on my current place of job, there's a separate team who works with this. Just make sure you understand what your metrics actually measure before relying on them. Mean values are tricky. Not long time ago, Stepan Davidovich figured out that if your initial set of values is not forming a perfectly normal distribution, you can get up to 40% time when your metric is lying to you. So, summarizing this part, main idea is to make process with minimal toil, which company can afford actually, and benefits matters right now on current company state. Okay, so now we know theoretical part. Let's continue with more practical questions. So let's be honest, not all services are equal. Some of them are more important than others, and before we can start doing anything with them, we need to group it in some kind of structure. So different security frameworks like ISO or NIST special publication, we have this thing called business impact analysis. Security specialists basically use it to determine criticality of a project based on how it impacts business from security, financial, or regulatory perspective. Of course, as person responsible for release process, you can do your own game and structure project whatever you think matters the most, but it's always better to make your process part of due care due diligence. In case if outage became a major security problem, you kind of like support company-wide efforts and not just stay aside. You can find security framework documents on this slide, written in blue colored text or in the video description. So, what is actually happening during the BIA? Long story short, security guys communicate with people, analyze services, and throw them into different buckets depending on the maximum tolerable downtime for business. If you don't have a security guy yet, or there is some rules or status quo preventing you from accessing this information, well, good luck. Now it's your job to do and support this stuff. What you do next, you get the BIA result and define release levels by drawing a line between different baskets to define where is business critical project and where is, let's call it business operational project with cost-effective quality assurance. And here you have it. You successfully determined what projects you need to concentrate the most and what will be the second wave and so on and so forth. You have limited budget for release stuff, so you can now efficiently kind of divide your forces depending on criticality of a project. The next thing to deal with will be the process itself. There are two types of releases. Scheduled releases and basically a hotfix. The difference is one of them is more urgent and you test less. Because outside factors do not rush regular releases into a production environment, we can plan all the testing we need. Regular testing during scheduled releases has two main impacts. It reduces the number of bugs inherited from version to version, and it provides the safest application snapshot. By introducing changes into safest snapshot, we cannot rely on previous regular release test results anymore. We have effectively no idea how it changed our system behavior until we figure out the hard way. That's why it's important to manage hotfix amount. If it's too much, the effect of a huge amount of work of different teams on release process will not be seen by clients. So how do we manage it? We cannot simply say no to customers who lose money because of uncaught bugs and they need our hotfix. Well, as previously described in part 1 at this time code, we can reduce or increase our release speed to kind of manage it. But before we start doing it, make sure it's not an issue with a technical realization of the process. If you pack the testing process one after another to match deployment of the previous version, with testing of a new one, like whatever obvious bug you will find in version 1, you will end up with the dilemma. Should you stop version 2 testing and just add new fix into the scope and restart testing and basically delay deployment? Or should you wait till testing is finished and add hotfix afterwards? None of this is ideal. Like, first decision has chance of dilemma reappearing in restarted testing, and basically you continue restarting it and never deploy. Second decision makes it so you never test it at all. And it will continue until you actually give some air to your process. The moment after release is finished, and you do nothing but monitor its behavior. Take a note on this graph, there is no x-axis timeline described, so reduce it. So the fact that testing line is kind of like reduced doesn't mean you test less. It just means you do not start test after test. You wait and look what's happening in prod. But also, we don't need to forget that the time between deployments should be small amount, so not so fatal bugs can just wait for another release. So here we are. Now what is left for me is to describe like different tools that you can use to level up your release process in the most simple way possible. First tool is is semantic versioning. It is really famous for being the most widely implemented versioning standard and, to be frank, the most wrongly implemented. So let me refresh my memory. Major change means backward incompatible API changes. Minor change means backwards compatible API changes, and patch means no changes to API at all. It is so simple, yet it's so much bias happening when you give people power to change the version. Architects want to reward themselves to some big changes in their diagrams. Devs want to celebrate big refactoring or big tasks done. PM want a major version every epic. The thing is, like, if you change the whole service and no API was affected, first, you did a great job designing API, and second, it's a patch version. There is just so much professional bias happening that the faultiest, stupidest implementation of automatic semantic versioning assignment is better than any human work. There is a place for something that's called marketing version, like Windows 11. And it's not in technical operations, it's for clients. The real world versions is ugly. Be okay with the fact that 3 years deep in a project releases, you will have like 100 plus major version changes in like the most important and interconnected backend services. So this is the part where I recommend to take pause on a video and analyze next 2 slides, because I'm not going to go in depth describing why somewhere it said minor version and somewhere is major change. The main idea is, will another service notice the difference if we roll back? I like semantic versioning, but it only describes public API. If the project you do versioning on is not just a library, but a service in a structured system, I would personally prefer to also check the external API we use. What changes in our representation of external API is backwards incompatible, so we can fully understand the answer to the question, is rollback even possible without making things worse? It applies on critical situation, of course. So if you try to release most of services on synchronized cycle, this type of versioning describes the state of internal communication. It has a pattern. You know what service changes are dependent on other services without looking into a core documentation. You just can look on versions and understand where the API was broken. The second tool is release consistency check. The main idea is not to microcontrol or replace PM project manager's job. Of making sure that tasks are facilitated in a meaningful way within, boundaries of acceptable timeline. The idea is to make human error less fatal. To create another quality gate that will find this kind of issues or inconsistencies before we start testing our product. It is extremely helpful to communicate with PM team and create some kind of agreement about what fail-safe mechanisms they need, what tasks need to be deployed on production simultaneously. For whatever reason, it cannot be done separately. And how they actually gonna mark this in Jira. Another tool, but more of a standard, is a backwards compatibility policy. Just make developers create new things and change all things in a backwards compatible way. If there's one thing that makes your life tenfold easier and doesn't make developers' life live in hell, it is. Specifically, helpful for backend services. The main idea in short terms, incoming traffic to your service is what your service's logic depends on to work correctly. Concentrate on maintaining the backwards compatibility on the controller requests API and response from external APIs, representation in your code. That's it, that's how you do backwards compatibility. It breaks change of dependencies that you need to track during production deployment, and you can roll back. Well, if you don't have some disruptive or, unrollbackable database migrations. But you get the point. There can be a question, why concentrate specifically on incoming traffic only? Well, let's look into all possible options. Let's imagine that if you have different teams that work on different interconnected projects, and you need to make sure that you provide them with simple to understand backwards compatibility rules, I shoved all the variations here. Specifically only the variations that covers the full API contract. You can make all teams responsible to do all communication in backwards compatible manner. Sounds great on paper, but if you have backwards compatibility problem between two projects of your company, you will have two teams doing homework, and the possibility of issue gonna be twice as less, until you realize that in situations when more than one team leader is responsible for something, literally nobody is actually responsible. The second row is basically delegating responsibility for our service correct work onto another team's or company's project's shoulders. If you can actually gaslight your teams into doing that, well, good luck doing that with separate company and their product you depend on. So here's our hero. Teams care only about making their servers work, no matter what changes are introduced. It's simple to assign accountability for failure, and it's kind of fair. So let's talk about options. You can make every backend service do only backwards compatible changes, or you can apply it based on business risk and overall project communicational structure. Creating what is effectively is release candidate group, test projects from the same group together, deploy them together. You decrease the number of moving pieces on prod by doing that, which may be good enough. The last tool I want to share with you is release impact analysis. It's basically a quality gate that concentrates all the automated checks you can do before you start wasting your time, basically wasting time of manual and automational QA. So what you can check? You can check database migration on disruptive changes, very useful for some kind of regulational stuff. Applicational property values checks, release consistency check from 3 slides ago, automated security assignment, or you can check what is libraries was connected in latest versions. Basically wherever you have issue with, it is the first place you go to prevent it from happening again. So there we have it. I hope you learned something valuable today. I had a great experience, to actually formulate all this information into words and structurize everything in my head about release process. And, remember, do care and show diligence in maintaining this process. It's important. Have a great day. And I would be glad if you will follow me on YouTube and LinkedIn.